here with ratio, to the giant marker again, starts with ratio. A rational expression is a ratio of polynomials. It has to have a variable in the denominator. So, for example, something like x over x plus 1 is rational. So, it will be, we're going to be dealing with expressions that are fractions that have x's in, at least in the bottom, usually top and bottom of those. So this is also going to mean we're going to need to review a lot of stuff for fraction rules, because I often find that a lot of my students are in high school and do not know how to do anything with fractions. Now, you can use the calculator for regular fractions. What you can't use the calculator for is whenever you have fractions that have x's in it. Desmos will not simplify x squared plus 3x plus 2 over x squared plus 2x plus 1, right? It'll simplify 5 over 10 for you, but it will not simplify stuff with expressions. So it's kind of going to force you to look at those fraction rules and think about how to do fractions by hand rather than just typing something into the calculator a little bit. So we're just going to do, what we're doing today is fairly straightforward. We're going to mostly practice with it. So the simplest form of a rational function is going to be whenever the numerator and denominator have no common divisors. So you can't divide the top and the bottom by the same thing. So if we're thinking about just regular fractions, let's think about what that means. So we've got like if I have 2 over 4, is that in simplest form? It is not. So if I divide the top and the bottom by 2, I would get 1 over 2. That is in simplest form because there's nothing I can divide both of those by, right? So that is what we're talking about here. It's going to look different whenever we have x's involved, and we're going to look at that in a second. So you have to simplify by dividing out the common factors, and this dividing out the common factors, that can be thought of as factoring. So you may have thought that we were not going to factor anymore whenever we did the last unit where we had to factor. We are going to have to factor some for this unit also. So let's look at some examples. Oh, actually, no, here first. These are Miss Martin's notes. So I usually say that there's a math fairy that dies if you do this, but she just went straight with kitten. Well, she probably got this from somewhere else too. I doubt she made that mean. But so when you are going to simplify a rational expression, which is what we're doing today, you're going to factor the numerator if it's possible. You're going to factor the denominator if it's possible, and you're going to reduce using the factors, not the terms. So what we're going to see is if something is on the top and the bottom, we can cancel those out as long as those things are being multiplied by each other. What you cannot do is something like you see right here where you have x squared plus 2x plus 1 over x squared plus 3, and you just mark out those x squareds because you have an x squared on the top and the bottom. The reason that you cannot do that is because those terms are not multiplied. Let me give you an example here. So like, for example, if I had 2 plus 1 over 2 plus 7. All right. Now, to simplify that, what you should do is just to get 3 over 9, and then 3 over 9 will reduce to 1/3. Okay? What you cannot do, if you do something like this, where you just mark out things on top and the bottom, and you got plus signs, that would be like me taking this 2 here and this 2 here and marking it out and say this equals 1 over 7. That would be incorrect. We cannot do that. Okay? Now, could I do that if I have 2 times 1 over 2 times 7? Okay? 2 times 1 times 2 over 7 would be 2 over 14. And 2 over 14 would be 1/7 if we reduced it, right? So if I have things that are multiplied, I can just cancel out that 2 divided by 2 and just get 1/7. Those are both correct, but they must be multiplied first. Okay, so let me show you in an actual problem what we're talking about here. All right. Well, let's do A first. B is where I'm going to show you what we're talking about here. So, if you are simplifying an expression, you need to factor the top and factor the bottom. The top of this is already factored. It's broken down into our sets of parentheses. The bottom could be factored a little bit further. Which part of that could be factored? The x to the second minus 1. So the top, I'm just going to leave it the same. And then the bottom, I'm going to have x minus 5. And then that x squared minus 1, I could factor it. Okay? This is one of those special cases where the middle term is missing. What could I multiply to get x squared? X and x. What numbers could I multiply to get negative 1? Negative 1 and positive 1, right? So I could factor that out further. Now, all of these factors here are being multiplied by each other, right? Everything's being multiplied by each other in those sets of parentheses. We do have plus or minus signs in the inside of these parentheses, but in between our separate factors, everything's being multiplied. So if I have an x minus 5 on the top, it can cancel with my x minus 5 on the bottom, because both of those x minus 5 divided by x minus 5 is going to give us 1. Cancels to 1. Same thing with my x plus 1 and my x plus 1 down here. So if you have something on top and bottom, once it's factored, you can cancel those out. So that would leave me with nothing on the top. But can I have nothing on the top? No, because I can't have a fraction that's just blank in the top. What number should I put there? 1. Okay, not 0, but 1. Because when these are canceling, something divided by self is 1. So we have a 1 up there. And in the bottom, I have an x minus 1. Okay, now, we like our Desmos tricks on this. So let's look at this real quick on Desmos. Wrong thing. So if I graph what the original looks like, x plus 1 times x minus 5 over x minus 5 times x to the second minus 1. If I graph y equals 1 over x minus 1, I'll see that I get the same graph there. There is a slight difference, like at positive 5 on the red graph. There is like a hole in the graph right there, but I don't think we have to talk about that right now, so we won't worry about that. But you can see that's the same graph, whereas if you had done something wrong, it may not be for that. Okay, questions on A? All right, B is not factored. And so what I was talking about earlier, what you might be tempted to do is say, oh, look, there is an x squared and an x squared, top and bottom. I'm going to mark those out. Oh, look, there's a 12 and 12. I'm going to mark those out. You cannot do that. Because right now, this stuff is being added or subtracted. We cannot cancel when things are being added or subtracted. So we have to break it up so that it is factored. So this is going to require you to remember how to factor. So whenever we're factoring, to get x squared, we would use x and x. I need the numbers that can multiply to give me negative 12, which would be negative 3 and 4. negative 2 and 6, negative 1 and 12, or I could switch the negatives on those, which I'm not going to list. What should I use to get a positive 1 right here in the middle? Negative 3, positive 4. So negative 3, positive 4. So that factors on the top. On the bottom, I would have an x and an x here. I've got a positive 12 right there on the bottom, so that could be 3 and 4, 2 and 6, 1 and 12. Which one of those would give me a positive 7 in the middle? 3 and 4. So positive 3, positive 4. And do I have anything now that can cancel? X plus 4s are gone. So those cancel out, and I get x minus 3 over x plus 3. And those will not cancel. I can't go start doing crazy things like marking out those x's and marking out those 3's and getting the negative divided by positive. That does not work, right? It has to be things that are separated out as factors. So this would be my answer for B. Okay, you guys try the next two. Try the next two on your own. Problems like number 1, because I didn't do any problems like number 1. Okay, so if you have something like this, that stuff there is being multiplied together. 60 times k over 20 times k squared. So the 60 and the 20, we're just going to reduce like we would reduce a normal fraction. What can you divide 60 and 20 both by? 20, right? That's, you could use 10, but then you need to reduce again, right? So that will give you 3 on top and a 1 on the bottom whenever you do that. You don't have to write that 1, but you can. And then what we're thinking about is we got just a k on the top and we got 2 k's on the bottom, because k squared just means k times k. So this k will cancel with this k right here. And what we'll end up with here is just 3 over, you can put the 1 if you want, but you don't really need to there, just 3 over k. Oh, yes, thank you. I lost that negative that's out front. Okay, so essentially when you have something, like if you've got k to the 5th over k to the 3rd, you don't have to draw this out every time, but you could. You got 5 k's on top. You got 3 k's on the bottom. Then you got 1 set would cancel, 2 sets would cancel, 3 sets would cancel. You got x squared. Would it go on the top of the fraction or the bottom? Top, because you got more left over. So what you're really doing is you're just subtracting those exponents, right? 5 minus 3 is 2, and you're going to put it wherever the bigger exponent is, because that's where the leftover x's are going to be, right? So that would be x squared. That's a side note. It's not any of these problems right here. So, for example, if we wanted to do number 2, 12 divided by 16, what could I use to reduce that? 4. So if I divide the top by 4 and the bottom by 4, I would get 3 on top, I would get 4 on bottom. And I've got 2 x's on top, 4 on bottom. So how many x's and how many x's are going to be left and where should they be? 2, and they'll be on the bottom. So 3 over x to the 4th would be your answer for that. Let me see if there's anything else here I need to go over. 3 and 4 are like that. Oh, we need to do 5. Yeah, those. So something like number 6 is like the ones we were doing, but the bottom won't factor because it's just an x plus 7. But what you're probably going to see is like on the top, you're going to have something times x plus 7, and that x plus 7 will cancel. So like whenever you have something like that, you just don't have to factor the bottom right there. It's like, well, we'll go ahead and do 6. So like this will be x, and x. We need to multiply to get negative 56. What numbers could I multiply to get negative 56? Negative 7 and 8, or the one I really need is negative 8 and 7, right, to get a negative 1 in the middle. So I have negative 8, positive 7, and I got this x plus 7 on the bottom. It doesn't have parentheses around it, but you could put parentheses around it, right? So the x plus 7's cancel. I end up with x minus 8. Do I need to put anything in the bottom of that fraction? I don't have to. If you wanted to put over 1, it's correct, but you don't have to put something in the bottom of a fraction. In the top of the fraction, yes. So if everything cancels out and you got nothing left in the top of the fraction, you have to put a 1 there. But in the bottom, you don't have to do that. Let's look at number 5 also, because I didn't do one like this. So the top, there's nothing you can do with the top. Well, there is something, but we'll have to see it in a second. The bottom, there's not like a variable I can mess with, but does that have a greatest common factor? 7. I could take out 7. So if I like divide both of these by 7, I would get v minus 6. V minus 6, is that the same as 6 minus v? It is not. So those can't cancel. Yeah, if it was v plus 6 and v plus 3, we could switch them. Or v plus, I'm sorry. If it was v plus 6 and 6 plus v, if we had addition, we could go ahead and cancel those. Because addition is commutative, we can switch the order of addition, right? But subtraction is not. 2 minus 3 is not the same as 3 minus 2. So if you see one like this where they almost cancel, but one of them is backwards, okay, here is what you want to do. You can factor out a negative 1 out of either the top or the bottom. It doesn't matter. I'm going to do the top. So if I like divide both of these by negative 1, that means I'd have a negative 1 out front. That would give me negative 6 and a positive v. And then I would have negative 1. I could rewrite this as v minus 6 because negative 6 plus v is now addition. I could switch the order. It's going to be v minus 6, 7 over v minus 6. I could cancel those, and I would just get negative 1/7 for that. So if you run into one like that, that will not cancel because they're just backwards, try factoring out that negative 1, and I'll get it to match. Okay, questions? All right, I'm going to skip down here and, let's skip down here and do 14 because that's one of the more difficult ones, and then I'm going to let you guys loose on your own. So, on 14, what's the first thing I always look for? Greatest common factor. In the numerator, do I have a greatest common factor? Okay, what is it? 5n. Okay, and so if I take out a 5n, it's like I'm dividing everything there by 5n. I will get 3n squared plus 2n minus 8. In the bottom, what's my greatest common factor there? 5n. So 5n, and I'll have 7n minus 3. This is different than I thought it was going to be. So, whenever I see this, there is something I can go ahead and cancel. What can I cancel? The 5n's, because they're multiplied by this stuff, right? And so I could cancel those 5n's. That's just going to be 1. I can try to factor the top. So to get 3n squared, I would have 3n and n. To get negative 8, I could use negative 2 and 4 or negative 1 and 8. And this is one of those where we've got to guess and check. It's not going to give you 2 in the middle. There is one that gives you 2, but it's not necessarily going to be the right answer. So if we try negative 2, positive 4, If we multiply that back, we get 3n squared plus 12n minus 2n. That one's not going to work. 12 minus 2 is going to give us 10. So that does not work. We could try switching the 4 and the 2. Put the 4 here, the 2 here. So that'd be 3n squared plus 6n minus, this one's going to work, minus 4n minus 8. So positive 6, negative 4, that gives us a positive 2 in the middle. So that is factored correct. Oh, gracious. That's factored correctly. This is just where I was checking. I'm going to get rid of that. And I've got on the bottom 7n minus 3. However, does any of that cancel? It does not. So you could leave your answer like this, or you could have left it up here like just this right here, because it's not going to cancel. And you can kind of see it's not going to cancel because 3n squared, you know you got to use a 3n and an n. Is there any way that's going to give you a 7n right there? It is not. So if you see that, you could just kind of stop and not cancel any further. So you won't see many of these where you've got to do that more difficult factoring, but there'll be a couple on there. Okay, questions? All right, you got about 15 minutes. If I'm seeing you guys work really, really hard, I might decide that I'll let you skip a few on the assignment. If I'm seeing you goof off, it's going to definitely be the whole thing. So we got about 15 minutes. Try some of these problems. I'll be around to help. You can also get your partner to help you if you would like. I guess. I hadn't printed new bathroom passes. I declare today Free Pea Friday. No, just today because I haven't printed new bathroom passes. One at a time still, though.